All right, so today we're going to dive into a paper that tackles something huge in AI, self-awareness. It's all about giving these incredibly powerful models something we take for granted, a gut feeling, a sense of when they're on the right track and when they're not. Let's get into it. Think about how you solve a really tough problem. You've got this internal compass, right? You can kind of feel when you're getting warmer, when you should keep pushing. But you also know when you've hit a dead end and it's time to just scrap it and start fresh. Now imagine, what if an AI could do that too? And that right there, that's the core issue we're talking about, this missing intuition. There's this massive gap between how our brains work and how most AIs are built to tackle hard problems. They're just missing that crucial layer of thinking about their own thinking. I mean, just look at the contrast here. It's pretty stark. We humans, we're constantly checking our work, we adapt on the fly, and we know when to call it quits. But a standard large language model? Nope. It usually just gets a fixed budget and uses a brute force method. It'll just generate a whole bunch of answers and kind of hope one of them is the right one. There's no real-time adjustment at all. And this brute force approach, this whole guessing game, well, it comes at a massive cost. And we're not just talking about being inefficient. It has very real consequences for anyone actually trying to use these things. The most common way they do this is a method called best of n. You might also hear it called majority voting. The idea is the model generates, say, 32 different solutions to the very same problem. And then some other system, or sometimes just a simple vote, tries to pick the best one out of that pile. It treats every single problem, whether it's super easy or incredibly hard, the exact same way. So here's the kicker. This approach is just unbelievably wasteful. By throwing the same fixed number of attempts at every single problem, you are driving up the cost in the time it takes to get an answer, what we call latency. It is literally like using a sledgehammer to crack a nut every single time. And this chart, wow, it really shows you the scale of the problem. When you're generating dozens of possible answers, most of that brainpower, most of that compute, is spent going down paths that lead nowhere. The vast majority of the energy and time is just, well, it's thrown away on dead ends and wrong guesses. But you might be thinking, there has to be a better way, right? Well, that's where this new research comes in. It offers a totally different and frankly revolutionary approach that gives these models a little glimpse of something that looks a lot like self-awareness. And it's called ZipRC. And it completely changes the game by giving the model the ability to look inward, to introspect, while it's actually working on a problem. To use the researchers' own words, ZipRC equips models with zero-overhead introspective predictions of reward and cost. Now, that key phrase there is zero overhead. What it means in plain English is that it teaches the model to ask itself two simple questions at every single step. First, how likely am I to get this right if I keep going? And second, how much more work is this going to take? But here's the part that's honestly kind of mind-blowing. It does all of this without slowing the model down one bit, without needing extra computing power. It's a zero-overhead trick, and it is just brilliant.
So how does this magic actually work? Well, it's surprisingly elegant. While the model is doing its main job, just predicting the next word in a sentence, it's also making these two extra predictions at the exact same time. It's estimating the final quality, what the paper calls reward, and the total effort to get there, what they call cost. And based on those two little predictions, it can make a smart call on whether to keep going down a certain path or just cut its losses.
And the real magic here is that this isn't some extra feature they just bolted onto the side. The researchers figured out how to get these predictions by cleverly reusing parts of the AI's existing thought process. Think about it like the dashboard in your car. The engine is already running to move you forward, right? That's its main job. The speedometer and the fuel gauge are just reading information that's already being generated by that process without burning any extra gas. That is the zero overhead trick. It means no extra cost when you're actually using it. It's just pure efficiency. So the big question is, does it actually work in the real world? Oh yeah, the results are seriously impressive. This isn't just some neat idea on paper. It delivers real, measurable benefits across the board.
Get this, on really complex math problems, the kind that mix easy and super hard questions together, ZipRC improved accuracy by up to 12% over the old brute force method. In the world of AI benchmarks, that is a huge leap forward.
And it doesn't just get that accuracy boost by throwing more power at the problem. It does it while being more efficient. Let's just walk through this table. Compared to the old way, which we'll call the baseline, ZipCRC gets that much higher accuracy. But look at the next two rows. It does this with an equal or even lower average cost. And because it's smart enough to stop wasting time on dead ends, the latency, the time you're sitting there waiting for an answer, is lower. It's better, cheaper, and faster. A total win-win-win. So what does this all mean for the big picture? I mean, where do we go from here? Because this is so much more than just a clever optimization. This feels like a really foundational step towards smarter, more reliable, and frankly, more useful AI. This technology enables a truly adaptive AI, one that can put more effort into the hard problems and breeze through the easy ones, just like a person would. That makes AI systems way more efficient and cost-effective. And this is a big one for me. It increases trustworthiness. An AI that can signal its own confidence, an AI that knows when it's struggling, is an AI that knows when to maybe ask for help instead of just confidently giving you a wrong answer. And that all leads to one final, really thought-provoking question. We've just seen how an AI can be taught a form of introspection, this ability to judge the quality and the cost of its own work. So, what's the next uniquely human skill it's going to learn? That's definitely something to think about. Thanks for joining us.